Have you ever wondered if we're truly alone in the universe? Or if there's more to our existence than what we see? What if the James Webb Space Telescope, JWST, finally proves that we live inside a black hole? Join us as we explore this groundbreaking discovery that will make you question everything you thought you knew about the universe. So, what exactly are black holes? They're like something out of a nightmare. Sure, you might have seen them in sci-fi movies, but the reality is even scarier. According to scientists, black holes aren't just pitch-black voids in space. They're actually massive amounts of matter squeezed into an incredibly small area. Imagine a star 10 times more massive than the Sun, packed into a sphere the size of New York City. The gravitational pull is so intense that nothing, not even light, can escape. Scientists have been fascinated by black holes for centuries, ever since they began pondering objects in space so massive and dense that they could trap light. The most famous ideas about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a tiny, dense core. If this core's mass is more than 3 times that of the Sun, gravity overwhelms everything else, leading to the formation of a black hole. Detecting black holes is no easy task since they don't emit any light. However, scientists have found ways to infer their presence by observing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it'll pull that matter towards it in a process called accretion. Additionally, when a normal star gets too close to a black hole, it can get torn apart, emitting X-rays as it does so. Black holes also have a significant impact on their surroundings. They can consume nearby stars, emit powerful gamma-ray bursts, and even influence the growth of new stars in some areas while stalling it in others. But where do black holes come from? Picture this. Stars, once magnificent and blazing, meet their ultimate demise in a spectacular explosion called a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes are born from massive stars that have reached the end of their life cycle in a supernova blast. Smaller stars, when they die, transform into something called neutron stars, which are super dense but not dense enough to trap light. However, if a star is about 3 times the mass of our Sun, it collapses under its own gravitational pull, forming a black hole. As these mighty stars collapse, something strange occurs near their surfaces. Time itself starts to play tricks. From the perspective of someone far away, time appears to slow down near the event horizon, the point of no return for anything falling into a black hole. It's like the star's clock ticks at a different pace compared to ours. Sometimes, when 2 smaller black holes collide, they combine to form an even bigger and scarier black hole. And if a black hole teams up with a neutron star, they create a colossal nightmare that defies comprehension. Scientists have been grappling with the scale of these cosmic phenomena for years. Black holes come in 2 sizes, huge and small. There's a sinister mystery surrounding them that we can't seem to unravel. But here's the twist. Small is relative when it comes to black holes. Stellar mass black holes, remnants of massive stars, can be as large as 10 to 24 times the size of the Sun. There could be as many as 10 million to a billion of them in the Milky Way alone. That's an astronomical number of black holes that could swallow anything in their path. But wait, there's more. Supermassive black holes are on the other end of the spectrum. They're millions, if not billions, of times larger than the Sun. They exist at the center of large galaxies, including our very own Milky Way. It's like a gaping dark void that's pulling everything towards it. Renowned physicist Stephen Hawking talked about black holes throughout his lifetime. His lectures were always insightful, but some of his theories couldn't be confirmed due to a lack of necessary equipment. However, there's hope on the horizon. A single scientific instrument is changing everything, and we're not ready for it. It goes by the name of the James Webb Space Telescope, also known as JWST, and it's here to plunge into the depths of our universe. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel, a testament to the potential of human ambition. Sure, we've launched other space telescopes before, and they've done their jobs just fine. But this bad boy, it's in a class of its own. The JWST makes the Hubble, which has dutifully served us for years, look like a mere speck in the cosmos. And the price tag of this astronomical wonder? A whopping $10 billion. Yes, you heard that right. That's enough zeros to make your head spin. And get this, it took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this marvel to life, not to mention the invaluable input from over 300 universities. But let's not forget the risks that come with such a grand undertaking. This isn't a venture for the faint of heart. The JWST is venturing into uncharted territory, pushing the boundaries of what we know, and taking us to places we've only dreamed of. Following a successful launch, NASA recently announced that the telescope has enough fuel to last more than twice its minimum mission life expectancy of 10 years. Since its launch, the JWST has made many incredible achievements. It traveled over 1 million miles to reach its orbit around the Sun, where it will reside permanently. During its journey, the telescope successfully unfolded its massive 5-layer sunshield and giant main mirror, both of which had to be folded to fit onto the launch vehicle. Now, after NASA has fine-tuned and calibrated it, the telescope is almost ready to go into full operation. One of the most exciting things about the James Webb Space Telescope was when NASA announced that it had captured its first images of starlight. The first image taken by the telescope was of a star called HD 84406, resulting in a mosaic of 18 scattered bright dots from the star's light, captured by the 18 mirror segments located on the primary mirror. NASA later released a new and improved image of HD 84406, in which 18 unfocused copies of the star were brought together in a deliberate hexagonal formation. Once the observatory successfully aligns the individual segments of the primary mirror, it will begin the image stacking process. This will bring 18 images on top of each other into one clear view. Thanks to its sophisticated technology, the JWST will help scientists investigate the early stages of the universe after the Big Bang. It will study what happened after the first stars formed, a period known as the epoch of reionization. This era refers to when neutral hydrogen was reionized, or made to have an electric charge again, by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also help scientists discover exoplanets, which are very difficult to spot because of the way they interact with their host stars. Its powerful sensors will be able to observe these planets in more depth, including, in some cases, imaging their atmospheres. Understanding the atmospheres and formation conditions for planets could help scientists better predict if certain planets are habitable or not. Apart from studying the assembly of galaxies, scientists study galaxies to see how matter is organized on a gigantic scale. This, in turn, lets us see how the universe evolved. The spiral and elliptical galaxies we see today evolved from different shapes over billions of years. One of JWST's goals is to look back at the earliest galaxies to better understand that evolution. Scientists are also trying to figure out how we got the variety of galaxies that are visible today and the current ways the galaxies form and assemble. However, most importantly, the James Webb Space Telescope will help us answer the most profound questions of all. Are we alone in the universe? And are we living inside a black hole? The JWST has already been on the hunt. And guess what it found? Compounds called polycyclic aromatic hydrocarbons, or PAHs, lurking around those gigantic supermassive black holes in 3 active galaxies. PAHs are carbon-based molecules with ring-like structures, and they're fascinating because they could be the building blocks of life. They also help astronomers track star formation. When ultraviolet radiation hits these PAHs, they emit infrared light, a sight that can be detected by the JWST's mid-infrared instrument, also known as MIRI, and that's usually a sign that there are some hot, young stars hanging around. But wait for the plot twist. A brave astrophysicist, Ismael Garcia Bernit from Oxford University, decided to take a peek at 3 active galaxies known as NGC 6552, NGC 7319, the spookily famous Stephan's Quintet, and NGC 7469. These galaxies are millions of light-years away, deep in the darkness of space. What Garcia Bernit discovered will make your hair stand on end. In those central regions where the black holes reign supreme, he found an abundance of PAHs. Sounds good, right? Well, here's where it gets chilling. The radiation near those supermassive black holes twisted the PAH's very essence, transforming them into larger, electrically neutral versions of themselves. The smaller, electrically charged pHs vanished into oblivion, as if devoured by the darkness itself. But there's a glimmer of hope. The larger pHs managed to survive because they found shelter within thin, dense gas-filled clouds. It's like they found their own protective cloak against the horrors of the black hole's wrath. Now, you might wonder why this dark twist matters. Well, it's a bit of a cosmic mystery. You see, scientists thought that radiation near these supermassive black holes would annihilate pHs and silence their infrared glow. But the JWST's findings suggest otherwise. It's like we've stumbled upon a clue that defies our previous understanding. But wait, there's more. We could be living inside a black hole right now, and we wouldn't even know it. Stephen Hawking predicted that at some point, a black hole would grow so big that it would eventually engulf the entire universe. After that, the only way out of it would be to reverse the gravitational pull of the black hole so that it spits everything out, a concept also known as white holes. Think of it as the universe's way of balancing things out. The JWST's findings are terrifying, but we can't deny that we're on the brink of an incredible discovery. Do you believe we're living inside a black hole? Let us know your thoughts in the comments, and if you enjoyed this video, don't forget to like and subscribe for more mind-bending content. Thanks for watching.